Hi everyone, in today's video I am going to discuss a very popular design pattern, that is singleton design pattern. So the chances are that you already use this pattern in your code, as it is the most used design pattern out there, right? So in this video I'll discuss what is singleton design pattern, how we can implement them in Java. So I will discuss both eager and lazy initialization of this pattern. Let's start this video with the singleton design pattern. So this pattern ensures that a singleton class or class which implements this pattern has only one instance, which is accessible globally through a single point, be it a public method or public field. So don't worry if you have not understood this last line fully, right? So when I explain this through the code, you will understand them easily. So be with me, right? So the main problem this pattern solve is to ensure that no more than one instance of the class should exist in an application, right? Now let's talk about how we can implement this pattern. To create a singleton class, first a singleton class should have a private constructor so that no one can able to create an instance of this class using new keyword outside the singleton class, right? So first we have to create a private constructor, right? So it prevents the instantiation of the current class outside this class, right? Second, we have to declare a private static variable of the same class which holds the instance of the singleton class, right? So basically this variable acts as a state. Third, we have to declare a public static method which returns the instance of the singleton class. So any class need the instance of singleton class can call this method. So because we have prevented the instantiation of this class using new keyword, so any class which needs the instance of the singleton class can call this method, and through this method we control its instantiation, right? So let's see its code. So here I have created a singleton class, and in this class first I have declared a static variable to hold the instance of this class. So then we have make the constructor private, so it prevents creating an object using new keyword outside this class. So instance can only be created in this class. Third, we have created a public static method. So any class which needs the instance of this singleton class can call this static method get instance. And in this get instance, so the code is pretty simple. First we are checking if this instance, this field is null, then create the single instance, create the instance of this class which is singleton, and after that return this instance. If the instance is already created, let's say someone already called this method, so in this case the instance is already created, so we return this variable, we return the instance of this class singleton. So we have already checked whether this instance is null, whether the instance of this class is already created or not, right? So this method, this get instance method, is not thread safe, which I will discuss later in this tutorial. This code only demonstrate how we can create the singleton class, right? So we will cover thread safety, locking in this video. I mean, just wait for few more minutes. We will cover the topics related to the locking, thread safety, right? So let's talk about let's see its class diagram. So the class diagram is pretty straightforward. So we have one instance variable, which holds the instance of this class, and we have the private constructor, and we have this public static method get instance which returns the instance of this class, right? So this is the class diagram of the singleton class. And now let's talk about how we can implement this pattern, right? So I have already discussed, I will cover both the eager and lazy initialization of this pattern. Let's first see the code of the singleton design pattern using eager initialization. So in this class, first we have the instance variable which holds the instance of this class, right? So it holds the instance of this class, and here we have created its instance using new keyword, right? Then second, we have private constructor which prevent its object creation outside this class, and also no one can inherit this class. So no class can inherit this class because we have created its constructor private. The third, we have the public static get instance method which returns the instance of this class, right? So any class need the instance of this class calls this method get instance, right? So let's verify this by calling get instance method multiple times, right? So here I have called the get instance method. So basically it's a static method, so you can simply call the class name dot the method name, right? So here I'm calling this method multiple times, you can see, and I'm checking whether the memory address of both this obj1 and obj2 are same or not, because if it returns the single instance, then the memory address of both these variables should points to the address of the instance of the single instance of this class, right? So let me run this code. So the code is running, right? So now you can see the memory address of both the obj1 and obj2, right? And both of them points to the same instance, same memory address, right? And when we do the comparison using double equals to, it compares the memory address, and it is some hexadecimal basically it's some hexadecimal code, so we don't have to bother about that. The only conclusion is, so no matter how many times we call this get instance, we get the same instance every time. So basically it ensures that only one instance of this class is created, right? Now let's discuss some important points regarding the eager initialization. So we have already saw the code of the eager initialization, so we relate all those points, right? So first, it is simplest approach to create the instance of the singleton class, right? So we directly created the instance using new keyword in of field, right? So in a instance variable, right? So the second, the object of the singleton class is created when the class is loaded into the memory by the JVM. So whenever we run our application, the classes are loaded into the memory by the JVM. So at that time, the instance of this class will be created, right? And because of this also, it's a thread safe. So as JVM ensures that the instance will created before any thread access this instance variable, right? So we don't have to explicitly use synchronize block or maybe or some other kind of lock to prevent multiple instance creation. I mean, JVM will take care of this, right? Now let's also talk about the downside of this approach. So the one downside is, as the JVM create the instance during class loading, right? So we are always creating its instance whether it is required or not in our application, right? So which leads to the resource wastage. And the second point is, as exception handling is not possible in this case because we are creating its instance at the field level, right? At the in the attribute. So we can't do the exception handling there, right? So let's see, it's one more variation. So basically instead of creating its instance in the attribute at the field level, let's use the static block and let's create its instance where we can do the exception handling. So let me show its code. This code is similar to the previous example except this is static block, right? So in the previous example we have created its instance using new keyword in this instance field where the exception handling is not possible, right? So instead of creating its instance in the at the field level, we can also create the instance using new keyword in the static block, right? So a static block is run only once when a class is loaded into the memory, right? So this implementation is also thread safe and ensures only single instance is created. So this is the other variation of the eager initialization, right? Now we have covered the eager initialization. Let's move to the lazy initialization. What is lazy initialization and how it is different from the eager initialization? So in lazy initialization, we create the instance of a singleton class when the static get instance method called first time, right? So in eager initialization, the instance of the singleton class created at the time of the class loading, right? So in eager initialization, the instance is always created whether we should use in our application or not. Whereas in lazy initialization, it is created when we use this in our application, when we call this get instance method first time, right? The second important point is, so in lazy initialization, the thread safety depends on the implementation, which we will see in our code. Whereas in eager initialization, it is ensured by the JVM that the instance will always be created before any thread exists. So it is by default thread safe, right? So let's see the multiple variation of the lazy initialization, right? Let's see its code. So here is the code and it is similar to the previous examples. The only difference lies in this method, right? So in eager initialization, we directly do the new and this class name in the field in the attribute part, whereas in this lazy initialization, we are doing the instance creation in this method, right? So let's talk about this method, right? So here when get instance method is called, we first check whether the instance is already created or not. So if the instance is null, if the value of this instance variable is null, it means this method is not called yet. Let's first create the instance of this class and then return this instance, right? And what happens if someone calls this method second times? If someone calls this method second times, it means this instance variable is already initialized. The instance of this class is already created, so we directly return this instance. This piece of code is executed only when the instance is null, right? So now we talked about this method and this code is pretty simple, right? The important point here is that this method is not thread safe, right? So what it means is, if multiple threads execute this code at the same time, let's say if multiple thread enters in this code block and see that the instance is null, so multiple threads can execute this line of code and create multiple instances of this class, right? So I mean, if this thing happen, it defeat the purpose of the singleton class, right? If the multiple instance of this class is created, then definitely it defeats the purpose of singleton class, which ensures that only one instance of a class should exist in our application, right? So how to avoid this? So to avoid this, we simply use, let's say, this synchronized keyword to make this method thread safe, right? So we can simply use this synchronize keyword, and it ensures that only one thread enters this code block by acquiring a lock and release the lock once it executed this code. So let's say if there comes a multiple thread, only one thread gets the lock, it enters this code block and it will check, okay, this instance is null, let me create the instance, return this instance, right? So once it executed this code, it released the lock, then the next thread gets the lock and it will check, okay, now the instance is already created, the instance is not null, right? So we return the instance, the previously created instance, to the other threads as well. So in this way, it ensures that only one instance is created, and also it is thread safe. If multiple thread executed, if multiple thread comes, then only one thread gets the lock, it execute the code, release the lock, then the other thread gets the lock and execute this piece of code, right? So this is how we can ensure thread safety in using synchronize keyword, but it has some performance penalty basically. So every time this method is called, there is a locking overhead. Now suppose first time locking is fine because we have to create the instance, but once the instance is created, again if someone calls this method again, this thread the thread needs to acquire a lock, then it execute this code and the instance is already created, we return the instance, then lock is released, again someone calls this method, again the lock is acquired, right? So every time this method is called, there is a locking overhead which impacts the performance of a code, right? So how we can improve the performance and also ensure its thread safety, right? So we can do it by using double checking lock, right? So what we do is, instead of synchronizing this method, we can synchronize this block of code, right? And why it is called double checking? Because it is called double checking because there are two checks. First, this one where we check whether this instance is null, right? So here we are checking without acquiring the lock, and the other again we check by acquiring a lock, right? So what is the benefit of this if clause? Let me explain this. Now let's say first time if multiple thread comes, right? So they see this instance is null, I mean the instance is not created yet. So now one of the thread gets the lock, it will create the instance, right? So instance is null, so new instance is created, and after that this instance is returned, right? Now let's say few threads enter this block, but after once the instance is created, the next time when any thread comes, when this method is called, it will check whether if instance is null or not. So the instance is not null, so it will not execute this piece of code. So we are basically, we make sure that the unnecessary locking overhead is removed. I mean, so in previous example, every time whether the instance is created or not, whenever the method is called, there is a locking overhead. But here, once the instance is created, this locking overhead is removed. This piece of code will not be executed, right? So so by using this approach, by using this double checking lock, we we remove the locking overhead which synchronize keyword created when we use at the method level, right? And one more important point here we use the volatile keyword, right? So what is the purpose of this volatile keyword? So in short, volatile keyword ensure each thread sees the current updated value, right? It prevents the cache incoherence issue. Basically, I mean, I'll cover the volatile keyword in detail in separate video, but for meanwhile, right, for this video tutorial, the purpose of this, I mean, just to be to very short and to the point, that this keyword ensures that each thread sees the current updated value, right? So that is why this volatile keyword is used, so that let's say if multiple threads, I mean, in multi-threaded environment, so multiple there might be a chance that multiple threads are executing this piece of code, and let's say one thread entered this block of code and they created the instance, right? So this, the value of this instance variable is updated and it is shared among the multiple threads. So once the instance is created, so other thread will also see its updated value. That's why this volatile keyword is used, so that, I mean, due to this cache incoherence, I mean, if the other thread miss this value, they again comes to this block, right? They again will create this new the instance of this class. So to prevent this kind of issue, Java provides this volatile keyword which ensures that each thread sees the current updated value, right? So this is all about the double checking lock, right? So far we have learned what is singleton design pattern, how we can implement them using eager and lazy initialization. So let's discuss some of the use cases where we use this design pattern. So it is used in a scenario, or in a, let's say, when we design some application or some utility, it is used where we don't require more than one instance of that utility, right? For example, logging. I mean, if you are working on some application, or if you have seen some code base, logging is used everywhere, right? And it is the perfect use case of singleton class, where we need its single instance in our application to log the messages, right? Similarly for thread pool and caching, right? We don't need more than one instance of these classes to use these features, right? So other use case might be to load some configuration setting for the application, which load once during application startup. So these kind of scenarios, or these kind of utilities is a perfect example of singleton class, right? So that's it for this video tutorial, and I hope you enjoyed this video, you enjoyed this tutorial, and you learned something new and useful. So please like this video and share with your friends, colleagues, and if you have not subscribed our YouTube channel, please subscribe our channel. So that's it for this video tutorial. Thank you very much for your time.